Hello, I welcome you all to this another interesting screencast. The problem reads: two boats leave the shore at the same time and travel in the directions shown. If VA is equal to 10 meters per second and VB is equal to 15 meters per second, determine the velocity of the boat A with respect to boat B. How long after leaving the shore will the boats be 600 meters apart? This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Alright, so we have two boats with different speeds in two different directions, and we are being asked to determine the relative velocity of A with respect to B, and how long after leaving the shore will the boats be 600 meters apart. So let's write down the components for each one of these. Okay, so let's start with A. So there we go, A. I will use blue like so. It will have components in those directions like so. And then B, I will use green. It will have components like those. Alright, so let's write them down. So this one is VA cos 30, and this one is VA sin 30. Alright, this one is VB sin 45, and this one is VB cos 45. Alright, so our VA, therefore, as a vector, just want to write it down, it's just equal to a minus VA sin 30 minus sin 30 I. Okay, mind you, this is our coordinate, our positive coordinate, like so. Okay, so this one here, it is X and this is Y, right? So this is I, then plus VA cos 30 J. Okay, then VB is going to be equal to VB cos 45 I plus VB sin 45 J. So we have VA equal to 10 meters per second, and we have VB equal to 15 meters per second. So they're asking us here to find first to determine the velocity of the boat with respect to B. So B becomes our frame of reference. So this is VB, VA with respect to B is just equal to VA minus VB. Okay. Alright, which is just equal to, we can plug back these in. Okay, we can plug them in. We plug this one there, right, like so. Let me move it like so here. Alright, then we say minus some more, we plug this in. Okay, there we go. So we have plugged everything in, and we know what VA and VB is. Therefore, VA with respect to VB, replacing these values in there. Let's work out. We can grab the calculator. So we have minus 10 sin 30, then minus 15 cos 45. So this becomes a minus 15.6066i. Okay, then we have 30, 10 cos 30, 10 cos 30 minus 15 sin 45. Sin 45. Then this we get a minus 1.9463j. Okay, so this is our velocity of A with respect to B. This is in meters. This is in meters per second. Alright, let's draw what this looks like. So it is something like this. It is something like this. Both are negative, like so. Does it make sense? It's supposed to make sense. Then this one is closer to the x, like so. Okay, very close to the x. I'll explain later. So this one is our VA with respect to B, and this one is our VA with respect to B in the x, and this is VA with respect to B in the y, and this is the angle here. Right. Let's find the magnitude. Magnitude of A with respect to B is just equal to A with respect to B, like so. Okay, which is just equal to square root of minus 15.6066, okay, squared, plus minus 1.9463 squared. Therefore, B with respect to A, magnitude, that's 15.6066 squared plus 1.9463 squared. Okay, so this gives us a 15.73 meters per second. Let me check it again. That's 15.6066 squared plus 1.9463 squared. Square root of that, 15.73. Alright, let me just check one thing. 10 cos 30 minus 15 sin 45. Alright, it's okay. And then into 463, and then 10 minus 10 sin 13, then minus 15 cos 45, 1560. Okay, that is fine. So let's find the angle also. This is tan inverse of the y component, which is negative 1.9463 divided by negative 15.66066. Okay, therefore our theta is just going to be equal to 1.9463 divided by 15.6066. There we go. Tan inverse of that, we have a 7.11 degrees, which is there. Okay. All right. So why does it appear like this? Okay. It appears like this because the speed of both A is lesser than the speed of both B. Okay, so we are being told that every second, as every second passes, VA with reference, or VA will be the difference will be 15.73 meters every second, right? So we can say let our we can assume that let our B here be our reference. This is B, and then this point here we can say this one is our A. So let's calculate how long it takes for it to cover a distance of 600 meters apart. So let me say, there we go. Okay, something like that. There we go. So let's say this is A, this is B. Okay, so let's now compute, and then these particular speeds, they are constant. Okay, because of that we can simply say our distance S is just equal to V A with respect to B. Our distance A with respect to B is just going to be equal to V A with respect to B times the time. Okay, and therefore our time is just going to be equal to S with respect to B divided by V with respect to B. So where just 1 minute. So where SA with respect to B, which is the distance, is 600 meters, and VA with respect to B is equal to, we calculated at 15.73 meters a second. So dividing the two, we get the following: 600 divided by 15.73. So this we get a 38.14 seconds. So this is the time it takes for the two boats to be 600 meters apart. So we found the time. That the two boats take for them to be 600 meters apart. We've also found the velocity expressed as a vector, its magnitude, okay, plus its direction. Okay, all right. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.